So what is a MAC table? A MAC table basically is a entry with multiple MAC addresses binded to a logical interface. So what does this mean? As you know, we have VLANs, and in this example we have VLAN 10 and VLAN 11. This is its name actually. It's not how a VLAN is represented in Junos. And we can see that this MAC address, in order to reach this MAC address here, the traffic should go via this interface. And in order to reach this MAC address, the traffic should exit via this interface. It's basically a phone book, and it says that in order to reach this this device, you should go via this way. So let's see how switching works and how a MAC is being learned. So we have one switch with an empty MAC table, and it has 3 PCs connected, which are in the same VLAN. PC A will generate an ARP request and will send it to the switch. The request will be encapsulated in a layer 2 frame with the destination MAC address of FFFF, which is the broadcast address. Okay, switch will analyze the source MAC of the frame and will create an entry in the MAC table. So now the switch knows that in order to reach PCA with MAC address of AA, you should exit via port 1. Okay, now that the MAC entry has been added in the table, switch will broadcast the ARP request to all of the ports, but not on the port that it received the traffic. PCB will drop the ARP request because he doesn't have the IP address of 192.168.1.3, but PC3 will recognize its IP and will send an ARP reply stating that 192.168.1.3 is at CC. So it says that PCC have MAC address of CC. So the ARP reply will arrive at the switch. The switch will add a entry in the MAC table, and now it knows that in order to reach PCC, the traffic should exit via port 2. And finally, the switch will analyze its MAC table, and it will see in the ARP reply that the destination MAC is AA, and the frame will be forwarded on port 1. And PCA will update its ARP table, and when next time when it will generate a frame or a packet, it will know that PCC have the MAC address of CC, and communication is established, and the PCA and PCC will start exchanging packet. This can be checked if we'll return to our topology here. Let's stop the captures here. Let's clear Ethernet switching table for this device, and also the Ethernet switching table for this device. When I say Ethernet switching table, I mean the MAC table. And I will put a sniffer on this port, like that, on this port, and on this port. So I will go ahead and ping 10.1, 10.10.10.2, which is this PC here. So let the ping run, and let's go and analyze the capture. So as you can see, the first packet or the first data which was sent is the address resolution protocol or ARP, and it is asking who has this IP and to tell this IP, which this IP is the PC1's IP. The PC4 here responded to the ARP request and said that this is his MAC address. Meanwhile, this switch here created entries in the MAC table, and now this switch knows that to reach this PC, which is PC4, you should exit via this interface, and to reach PC1, which have this MAC, you should exit via XE001 interface. And if I'll go here and show Ethernet switching table, you can see that these entries here are reversed because of the connection. So QFX1 here sees PC1 available through this port and PC4 available through this port. But let's go to the PC1 and issue show ARP. Let's issue a ping again and show ARP. So we can see that it created an entry in its ARP table, which is stating that PC4 with this IP address have this MAC address. It generated an ARP request again because of the timeout. But let's see, the ARP entry is still available. Let's do another ping here. And another ping. And if you go back to our capture, you can see that we don't have any ARP packets generated at all, because there was an entry in the ARP table. But as soon as that entry will expire, and it will expire because it does have a timer, it will generate a new ARP packet in order to reach the desired destination. And as you can see, after that, the communication between them is happening without any issues. So we'll have traffic from PC4 to PC1, to PC1 to PC4, and so on. Thank you for watching, and I hope to see you in the next one.